Yeah, welcome to my presentation. This is about the NAT64 day 2019 at my company, which is called AWK Group. So this is about the experience we faced or we made when we placed our clients, managed clients, into an IPv6 only network. Although all our, let's say, internal resources, application services are running on IPv4 only. So since I have a lot of slides, as you can read offline. About the agenda for today. So I have a quick introduction, including the motivation, so why I came to this idea to do this. I will explain the test setup, and then I will report about the test results. And then I have some little surprise, some other test results. And then we'll conclude with some discussion with you, and maybe if you have time, some 2 challenges. Yeah, let's see if time remains. So as Enno very well introduced, this is my motto, and I think this English saying is a very good one. So it says that the proof of the pudding is in the eating. So you have to make your hands dirty to experience it. And when I started it and submitted the talk, I was thinking myself, can we do it at all? And if I want to do it, or if I'm doing it, how complex is the setup? So it's easy going, or if it's really hard and tough. And also when we come to the conclusion, is it really an alternative to the dual stack setup? So before we start, a very, very quick recap. Who was not in the talk of Veronica this morning? Okay, so, but you know it, Frank, right? So I don't need to tell you. So basically, if you have clients in IPv6 only network, and they should can also be able to connect to IPv4 resources. The trick to doing so is to leverage DNS. So basically, you spoof or you modify DNS responses. And yeah, so if you have only a resource which is only available over IPv4, some device in the middle is recognizing the response, which is empty for a quad A record, and then it spoofs some kind of response to the client device, which then is sent to the client, which is only v6 able. And you also need some network device, which then translates this IPv6 as a special IPv6 address back to an IPv4 address. I guess there's no question, right, for the audience here, so because you should be familiar with this. So the test setup. So this is a very high-level picture of the, let's say, network architecture of my company. Centrally, there is our SRX240 firewall cluster, which basically serves all security zones. And the security zone, which is of interest for today, is our trust zone. So in the trust zone, we have all the internal resources like file servers, SharePoint, everything which is which needs to be protected and needs to be accessed from internal is placed here. And also our clients, also of course in different networks, they are placed in this trust security zone. And you can also see the other, let's say, also high-level topology. So you can see that we also have, next to Zurich, we have 3 branch offices in Bern, Basel, and Lausanne. And what is also kind of interesting for this talk is that we have a layer 3 VPN to Swisscom, which is hosting our Skype for Business infrastructure. And yeah, so I also had to make sure that the IPv4 traffic I'm generating as a SX firewall towards the Skype for Business server is properly routed. I also tried to indicate with these colors. So blue means it's an IPv4 only, IPv6 only LAN network or segment, whatever. And orange means IPv4. So you can clearly see that all the resources which you have in our trust zone are IPv4 only and cannot be accessed by IPv6. And what is also important, if we will later look on the, let's say, network trace and everything, so these are our 2 DNS servers. And also you can see the hexadecimal representation of our DNS servers, which you will see in a lot of traces later on. So for reference, I also included the configuration. The entire configuration can be found in the appendix of the slides. So as I said, I installed an additional SRX300 firewall in our network, also that I don't have to interfere with our daily operations by modifying or pushing too much config changes on our production firewall. And as you can see here, this is an interface pointing to the IPv6 only network, and it has only an a global routable IPv6 prefix and this link local address, which I really like to, on routing or layer 3 network elements, I like to hard configure the link local address, because then regardless if you get an address or something, you always will see this link local address by some neighbor advertisements or router advertisement, and you quite easily can see in which network segment you are. Then I've of course set up another physical port which is then connecting to the AWK trust zone, and obviously here we need a dual stack network, considering that this firewall will act as a NAT64 gateway. And then I've also set up NAT64 with static net, and I've also set up the NAT64 with static net.
Question.
Yes?
Is it intentionally that you have configured the FE80 in the upper line to be a /64 out of an FE80 colon 6?
Might be that.
So that you have.
So I didn't get the question, to be honest.
So in the second line, the FE80
yes.
colon 6, and then you have 4 hextets again.
So
the 6 is just on the left-hand side from the /64. Is this intentionally? Or is
this is intentionally because this would match then this basically. You know.
yes,
Exactly. Yeah.
Okay.
It seemed to work. Yeah. Okay. What is important, but this is a technical detail, that for the NAT64 rule, you have to not match only the destination address, but also the source address. Otherwise, for whatever reasons, the firewall was applying static NAT64 to IPv6 traffic, and he logged it accordingly and said, I cannot forward the packet because it has not, as a source and destination IPv6 version is not matching. It was a bit strange, but yeah, it was easily detectable and fixable by me. So, as I said, I used the static net, which is stateless, right? Any idea why? So it's because, or this might be a second hint, this table from Cisco. So it's because of this. I wanted to have really a one-to-one relation. And compared to the use case which Enno and Christopher presented earlier today, where this supermarket model, where the clients just want to have internet access to connect to some services, I was considering that my clients will not connect or initiate the connection, but there might also be connections coming in towards the client. Like, for example, if our software deployment tool is going to deliver some software to the client, it needs to be able to access the client. And so this, without having any very complex network address translation or states, keeping states on the firewall, I wanted to prevent this. And with Juniper, it's quite nice. You have to. I spent 1 or 2 hours to fully understand it, but then you can really, with so-called pools, static net pools, you can really relate or to create a really one-to-one relation between an IPv6 and an IPv4 address. So that really every time the clients get this address, it is a one-to-one relation to this 128, 81 is related one-to-one to 129, and so on. And this was also, what was also important that I was using this network, because this was one network which this Skype for Business router from our service provider was routing this network. And to be honest, it was more work on our Windows DHCP server to split the /24 network into two /25 networks, because you cannot easily or simply modify the net mask on Windows DHCP servers. You have to remove the config and reapply the changed or modified configuration, as I had to learn. Let's see. Okay, and then next would be what is also very nice. It's, as you can see, it's if you look at the configuration, we have only two NAT rules. I have one NAT64 rule, which seems to do only the destination IP, right? So it says if the destination address is looking like this, you should do static NAT, which means he rips off this IPv6 prefix and creates the IPv4 destination IP. And the same here. The other way around, if you have a destination address of an IPv4 destination address in this range, you do this static NAT for the destination IP again. So we have two rules which seem to work only for destination IP. Now the question would be what I do with the source IP, which this should also be modified in order to have either an IPv4 to an IPv4 connection or an IPv6 to an IPv6 connection. And this is the beauty of the static NAT that I call it the beauty of static NAT at Junos, that these two rules are also applied in reverse order. So if the opposite occurs, he is going to, if he sees such a packet that with a source IP of this in this range, he's going to apply he's going to change it with the proper source IP address. So basically with two NAT64 and NAT46 rules, you can cover the whole setup, which is also from a configuration point of perspective very nice. And as you can see here, what the firewall does implicitly, it's changing the destination term with the source term. What is also important to know, at least in the scope of Junos, is how or by when the policies are evaluated by the firewall. Because, for example, you can see here in the trace, he tells me, I found a packet with a source address, or IPv6 source address to an IPv4 destination IP. And this is important because of the flow processing at Juniper firewalls, which at the beginning, when the packet enters and there's no existing session, what the firewall does first, well, these are some upper layer security mechanisms, which I don't have a look at. But then, secondly, static NAT is applied for the destination IP. Then there's some route lookup and security lookup. And then the policy check is applied. So he's looking for a firewall policy which allows or denies the traffic. And only then reverse static NAT is applied. So what you have to do, basically, it's a bit strange. You have to specify firewall rules with considering that the client is sending some traffic or initiates some traffic from IPv6 to IPv4, which you have to know, right? Otherwise, you would think, okay, if the client initiates a connection which will end up in an IPv4 connection on the firewall, it will be an IPv4 to IPv4 address policy. But this is not the case, as you can see here, for example. Yeah. So he's saying he's found the policy from an IPv6 address to an IPv4 address. Yeah. I configured the firewall, and then, okay, I did the NAT64 part, and then, as we saw at the very beginning, you also need the DNS64 stuff. And well, I configured the firewall, I connected some client, and I was doing some ping, which obviously was working. And then I recognized that DNS-related stuff was working as well without that I did anything. So, and this is due to this feature in Junos, which is called Dns Doctoring Feature, which when I found out about it, I remembered that it a few years ago really nearly ruined my firewall migration because it did some unwanted DNS translation. But in this case, it's nice. So there's a service running, and it's running by default. So if you don't want the service to be running, you have to explicitly disable the service. We can now argue about it, but I skip this part. So what you can see as an example here, I'm doing an NS lookup from the client in the IPv6 only network, asking for a quad A record for this URL. And as you can see, the answer is I get a synthesized DNS record, quad A record. And sorry for that. So you can see when you look at the trace on the firewall, you can really see that the firewall is recognizing that it gets an A response from a v4 server, and it does not get any quad A response. And what he then is doing, he's translating an A response into a quad A response by exactly prepending this IPv6 prefix to this IPv4 address. And then he says re-inject the dump, so send the reply out to the client. And from the client perspective, it's really the client is asking for a quad A record, and he's receiving a quad A record. So it's like magic, yeah. So later we will see some limitations of this magic. Yeah, okay. And also to conclude with the test setup, what kind of test tools we used or to validate settings. So of course I tested the application itself. I was having a lot of looks into the Windows log, especially for Active Directory related activities. I used Wireshark, and also one tool I found really nice is this TCP view. I don't know how many of you knows it, but it's very nice because it lists you all the open connections and open sockets, and you can easily see the protocol used, right? So this is really nice. Any questions so far? Okay, so let's go to the test results. So again, to remind you, the conditions are that AWK clients were placed in an IPv6 only network segment. And within the network, the trust zone, so there was 2 firewalls in between, but I applied to any allow rules. And I allowed IPv4 and IPv6 internet access. And of course, the focus was on the internal applications, but also on the applications. We are a consulting company, so we also get a lot of tools from our customers to work with. Also with some of the tools we get from our customers to work with, because those obviously must also work. Yeah, so coming to the test results, I'm sorry, I only recognized a few days ago that's all in German, so the ipconfig output, but I guess you will get it, right? So yeah, so I'm getting an IPv6 address, and you can see it's I get it by DHCP. I also receive the IP address of the router, and I'm receiving these 2 DNS servers I mentioned before, which are our internal DNS servers in my company. And also the famous Windows network logo tells me you're connected. This is always when our network IT guys are starting to get irritated if there's a exclamation mark here. Not myself, but some people get nervous if there's an exclamation mark. Yeah, so routing table, obviously we don't have any default route to the IPv4 world because we are in an IPv6 only network, and I got a default route to my SRX300 firewall. Then also other commands to get more details about the IPv6 configuration the client receives. So first you should use this command to find out the interface number of the interface you're looking at. And since I have some VM network interface and so I have plenty of network interfaces, so yeah, it makes sense to look at the right one. And this is Ethernet 19 for whatever reason. And you can, for example, see the router lifetime of which was advertised. On the router, obviously, you should see some DHCP bindings. So the IP address is handed out by the DHCP server. And the client device unified ID. So it's here. I can also see the sessions, which are also the flows. And this is also, again, obvious if you really connect to IPv4 content. The incoming packet from the client is an IPv6 to IPv6 connection, but obviously the outgoing connection, which is then done by the firewall, so firewall forwards the packet to the IPv4 vault, then we have an IPv4 to IPv4 flow, as Juniper calls it. Okay, that would be the very basics. Now we come to basics findings. So one of the first tests I did was pinging. So this is our print server. And as you can see, I get a response. What is also nice to know is if you do ping, you have to know this prefix, which, for example, Troopers here is using a different NAT64 DNS prefix. But if you know this prefix, you can even ping IP addresses by using this prefix and then even using the decimal IPv4 notation to ping some IPv4 addresses. Yeah, this was the first issue I found which is not working. So what Windows clients typically do when they are configured to be in an Active Directory domain, they register in the DNS. And this is not working. So you see already, he tells me server, okay, I have to translate it, server to which the update has been sent, and you see an IPv4 address, which is some sort of strange. The process is that the client is sending a start of authority query to for this specific host name, or specific PC, sorry, in this specific domain, and he gets a response. And then he sends another query for a name server for this domain. And as you can see here, the problem, what he does right, so I get this name servers, which are the names of our name servers. This is good, but what is not good is that in his additional section, he is sending IPv4 addresses. And my conclusion is that he's using this one of these IPv4 addresses to now try to open a connection to the Active Directory, which of course fails because he does not have an IPv4 socket to do so, right? Because if he would properly now, would then issue another name or quad A lookup for AD11, it would work again, right? Then my firewall would intercept it. I was also opening a ticket at Juniper and asked, because this DNS Doctoring Feature, this is where the DNS Doctoring Feature is failing, right? So there's some additional stuff and it's not modified by the DNS Doctoring Feature. And I was asking the Juniper guys, hey, can you give me some specifics about this DNS Doctoring Feature, how it's working? And they said, the only thing I got as a response was that they're using this RFC 6147, and they implemented the DNS Doctoring Feature according to the specifications of this RFC. Okay, so GPO processing was working fine. So at least according to the logs. So he said that GPOs have been successfully processed. It was 28 GPO objects which has been detected and applied. So this was good. Also NTP was working. So he tells me the time provider NTP client is currently receiving valid time data from Active Directory 10 of my company. So this was working as well. What was I didn't found the issue, but after 1 hour, and it's a bit suspicious because exactly 3,600 seconds, he was losing the default gateway. And by losing the default gateway, he stopped connecting to the network at all, right? So this was very, very strange. I will come. Yeah, this was what I said. So coming to the, let's say not the basic functionality, but now coming to the real applications we use in our company, which were working fine. So file access, so we have a lot of network shares, which most companies still, I guess, have. No issue, SharePoint was no issue. I could also connect to various servers via RDP with this mstsc.exe. Skype for Business was working. You can see what we tested here in detail. So I was calling from PTSN towards the client, vice versa, and also video calls were working in both directions. Printing was working. AWK it's called. I think it's a Swiss company which providing our ERP software. It's Java-based. Outlook, even the Cytic NetScaler, which we use for management purpose, it was also working without any issues. So what was not working? Microsoft Teams. So it's because you said it's working for you. Yeah, it's funny. So I could do doing call outs, even with video, to a colleague. But if the colleague was calling me from an IPv4 network, the signaling seemed to work because it was ringing. But immediately when I said I pick up the call, it was disconnected. So it was. And then we have a solution which we barely use. So this is anyway we will not use it in the future. It's some secure cloud storage location, which we're not very convinced of. It was more some sort of trial in my company. So this was, let's say, AWK internal applications. Now I also had a look at external applications, and you might wonder, but I really at the moment have a customer which is giving me access to some internal resources of him or some shared resources via OpenVPN. I like it. So. And yeah, so OpenVPN was working. Obviously, when you're having a domain name and not a fixed static IPv4 address. Skype was working. Speed test. This is at least in Switzerland, it's a very common tool to test your internet speed. Google Drive, I'm using personally for some backups. And WhatsApp desktop app I tested. This is just an example that I could connect to my home firewall by just prepending this special /64 prefix, and this was working. What was not working? This speed test. There's also an app of the speed test which you can install locally on your PC, and this also I tested here. It's also not working in the Troopers network. And what was also very problematic, because this also a lot of customers of ours are using, is this VMware Horizon. Both versions, so there's a local client you can install, and there's also very nice and good web-based integration. Both were not working. I could connect and authenticate and everything was working, but as soon as you should have started to display the screen, it broke, so there was no screen shared. Or once I saw a desktop, but it was like very unstable. And yeah, in the Troopers network, it is also working sometimes and sometimes not. Yeah, this is also problematic if you give the client an IPv6 only connection, and if this IPv6 connection is broken somewhere else, so not on the LAN segment you connect the clients to, but in between, of course this is very problematic, because the client will only connect over IPv6, and he gets quad A records, and then also this NAT64 will not come in place. And so one example would be this one. So what you see basically is IPv4 content, which is still displayed, but you could say it's a good ad blocker, but yeah. Obviously, it's not good. So this would be one drawback compared to a dual stack, if you compare to a situation where you provide the client a dual stack access. Yeah, so as I said, some additional results, because I promised to put the clients into this IPv6 only network, the AWK clients. And I did so, but not as I announced it in the talk for the whole company, because we did a pre-run with roughly 10 clients, and given some severe issues we faced, as I just presented, there was a no-go decision from IT and CIO. So I said, okay, I cannot come to Troopers with that. So yeah, and also given that in the meantime I had a chat with Christopher and Enno, what we did as an IPv6 day at my company, we placed the AWK guest Wi-Fi into an IPv6 only network for several hours. And this is the technical setup. So what I did, I hooked this, basically it's a VLAN, which I removed from the SRX and connected to the SRX 300, which again did NAT64 and DNS64. When I prepared the configuration and tested it, I first used this public Google DNS servers, and it was not working for IPv4 content. And my observation was that DNS doctoring was not working any longer, because DNS doctoring seems to look at this special prefix to filter out DNS requests and responses. In the meantime, Johannes told me that there's DNS64 public DNS server provided by Google, which at that point in time I did not know, so otherwise I might have used that one. So I had to, it was a bit ashaming, because I had to, in an IPv6 network, I had to give the clients synthesized IPv4 DNS servers. But yeah. Any question to this second setup? I think it's quite straightforward, and it's basically also what we have here at Troopers. This is the configuration. In the AWK client setup before, I used DHCP, but here, because the guest Wi-Fi at AWK is, as the name suggests, not only used for guests visiting us, but also for all, let's say, devices which also AWK employees use, which are not managed by our IT. So it only gives you... I don't have so much, but all the mobiles, right? All the mobiles, they're not managed, so they get only internet access. And also, if you get a laptop from a customer, you connect to this Wi-Fi network to reach the internet and the customer resources. So I configured Slack as well, so stateless address configuration, and I did as well the RDNSS setup, as well as providing DNS information via DHCP. I really liked this morning. I liked your approach, telling the clients two different DNS servers with the two different mechanisms to find out what the client is using. Actually, it's really a nice approach. Obviously, since I was doing this company-wide, once I had configured it, I also did some not only advertisement communication to my colleagues. So I sent out multiple emails and reminded them that at that specific day they might have issues, but they should not have issues. And of course, I asked them to give me feedback, giving me feedback by filling out some feedback form, or I was available in our lounge, which is our, let's say, centralized coffee area, and also showed interested people some details of my experiment, let's say. Yeah. And then I switched it over for 3 hours. And in the meantime, as I said, I was present there, and a lot of people came by and were asking stuff. How I was observing it, so I was observing it on the SAX itself. I was using NTOP NG, and since I integrated the firewall also in our monitoring tool called Observium, I also had a look at Observium. So some screenshots to give you an idea of NTOP, Observium. Here you can see the number of flows or the concurrent connections, let's say. It's everything, every time the same for years in this microphone. Sorry for that. Some bandwidth. As I said before, but maybe it's related to my potential misconfiguration of the router. The biggest hassles I had with Windows 10 laptops. So 10 minutes after I started this, the first colleague came and she said, I have this customer laptop here, I cannot connect, and she was not getting any IPv6 address. And basically I told her to connect to another network because she needed to work for the customer. And but except this, I saw two users and they showed me it on their mobile. There was some sort of flapping internet connection. So it was saying, I have internet connections and I don't have any connection. A few minutes later, I don't have internet connection and so on. And I really looked at the phones and I was making sure that they had not mobile data activated or something. So it was really very strange. And it was two users both running Android devices with version 6 and 9. And yeah, this would also be a question to Enno and Christopher. Did you test the Revolut app when you're doing this? Okay, because it was working, but the verification SMS I did not receive. So sometimes they require you to validate that you are you with some SMS, which they send to you. And my impression is that there might be some IPv4 configured in the app, which is used as a destination IP to requesting such a verification SMS, and obviously this will not work then. So this was apps which were reported to me working, and because this was also a topic earlier today, also this one user showed me that his iOS VPN for calling home to his Fritzbox, this was working, obviously with an URL. And yeah, so I guess maybe I just some apps which you might not know because there might be some Swiss related. So this Revolut I mentioned, the SMS verification was not working. This is a Swiss newspaper. This is, I didn't know it, it's some Android browser. This is Twint, familiar with Twint? Some payment with mobile payment. So I think it's QR code based, or you can use also NFC. This is a very popular German radio station. This is Migros, like I don't know, AWK here in Germany, Coop, some grocery stores. And the speed test. And mobile ID is might be interested because this is some, I think it's Swiss related, so that you have a two-factor authentication method. Frank, you know it better than me, right? No, you don't know it. Not. It's. I think there's some security operations executed on the SIM card. So as long as you own the SIM card, you can some sort of prove that you are you. Yeah. And yeah, so this would be an example of what is not working. So we're still introducing a new Wi-Fi platform based on Unify, or this Ubiquity Wi-Fi access points. And I really like the GUI. but as you can see, there's space to improve because it nicely lists you all the client IP addresses, but it seems not be able to get the IPv6 IP addresses the client is receiving over Wi-Fi. Yeah, as I mentioned, and this should be a short recap, I had a lot of issues receiving proper IP addresses on Windows clients. So basically you have these two flags in IPv6 which are distributed with the route advertisements, management, and the other stateful configuration flag. And giving the combinations, the client should either choose stateless auto address configuration or should try to receive an IPv6 address via DHCPv6. And the same applies for additional information such as DNS servers. Since I had a lot of problems, I was also looking what actually my SRX is sending to me. And so I confirmed when, for example, this is an example where M and O flag set to 1. And I could see this here in the trace. And I could also see the RDNS options, so the DNS servers starting here, and 8.8 and 4.4. Yeah, and then I did some testing. And so we have always two entries. So the first one is if I use the Ethernet cable, and the second one is when I use Wi-Fi. And I was a bit, so I could also, this is a very old Windows version of which I used. This was it was even a laptop which is not configured to be in our Active Directory, or so in our company domain. It was a plain Windows 10 installation, no updates, nothing. And so only basically Ubuntu and macOS more or less behaved as I would have expected, given the flags. But what irritated me a lot is that I had different behavior looking at, or when I connected via Ethernet cable compared to the Wi-Fi. I'm not sure if Windows is using different network stack, or it was very strange. Okay. Sorry, you don't? We don't have old builds. Okay. Well, I hope this is quite a new build, because this is laptop which I'm productively using. So this should be not too old, hopefully. And yeah, but I might have to look, also given the input from Johannes, I might have to look again to my firewall configuration. But what irritates me is that I get proper results when I'm using Ubuntu or macOS. So it's that's done. Okay. 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 So would be the last slide of our test results. Some conclusions. So I was really surprised positively that the technical setup was quite easy and straightforward. I don't have to a lot of hassle but to configure it. And especially this DNS Doctoring feature could be quite nice for, let's say, smaller setups where you don't want to have an additional DNS server and so on. So, for example, branch offices or so could be really a nice thing to have. Yeah, as I already mentioned, I really was surprised to see that quite a lot of stuff is working without any restrictions. At least we did not find them. This applies to both test scenarios. But I have to say, I'm not sure if it's really less complex. At least, let's say, our initial scenario where we had this one-to-one NAT. We could also discuss quickly if you think this is required, right, to having this bidirectional connectivity. I think in an enterprise environment, it needs to be either you have this bidirectional connectivity, or before you're doing, before you introduce an IPv6 only networks for clients, you leverage all the centralized server infrastructure to be dual stack or IPv6 only with some dual stack gateway in front of them. But otherwise, as I said, the use case for me would be that our software distribution tool would like to send some software to a dedicated client, and this would fail in this setup. Yeah, so basically that's this. If any questions? I have some, we have still time, oh? So if you, yeah, okay. So I have 2 challenges. No. Come on, you just had lunch, so it was not necessary. So first one is, so it can, this is this newspaper news site I showed before, so I can easily access it or not. It's waiting for some result of. Let's do the other one. Now it's coming. Okay. So this is, I'm now in the Drupal network. And what I'm now doing is I'm starting a VPN connection to my company. Okay, now it's connected. And if I now, it's not any longer reachable. So quiz, why it's not working any longer? Johannes? Split tunneling not enabled, exactly, because what my VPN client is doing, he's sending all DNS requests now to our company DNS servers, which then of course returns only A records, and yeah, so, and he also gets not any IPv4 connectivity. And split tunneling for the content, right, so only only certain networks are routed through the VPN tunnel. If I would route also the internet tunnel to my company, it would work again, right? But it starts to fail already with the DNS. Because this, of course, they cannot intercept. But one maybe important information for Enno and Christopher. So he is using IPsec, as I could see. So it's encapsulated here. So, and this is working quite well. Basically, I was, when I did the very first test, I was saying, oh, everything is working? And I said, shit, no, the VPN client is still on. So he was tunneling also in. Yeah, exactly. Okay, this would be